In this video, we want to show that the integral on the left is equal to the result given on the right. If you want to give this a try, go ahead and pause the video, and I'll be right back. Now we could use a standard u substitution for this one. Let u say equal to a plus bt. Here the variable of integration is t. A and b are considered constants here. We've got an unknown value for the upper limit here of the integral. I just work it as usual. And then of course here du then would equal to the derivative of the right side with respect to t, would just give me a b dt. Divide both sides by b. So dt would equal to du over b. Or you can do it without actually going through those steps. I can just go ahead and say, okay, this is going to give me the integral from 0 to x of a plus bt dt. And then just proceed. The integral of sine is minus cosine. And this would be, the argument would be a plus bt. And then again, you'd have to divide through by the derivative of this argument here, this expression here. And I've got a sign here. This should be sine. So here I'd have to divide by b, or multiply by minus 1 over b. And then we evaluate this thing from 0 to x. Lower limit of 0, upper limit of x. And then I'm just going to factor out the minus 1 over b. So it looks like the given answer there. And I'll put brackets here. And then evaluate at the upper limit, put at x where the t is. I get cosine of a plus bx. And then subtraction here. And then evaluate at the lower limit here. Put a 0 where the t is, and just get cosine of a. Remember, the minus b is already out in front. But the minus 1 over b, I should say. So this then gives me cosine. Put a 0 where the t is, that gives me 0, where a plus 0 is a. And close the brackets. And that's the way it's given over here. Obviously, you could multiply through by minus 1 over b, make this minus 1 over b, cosine a plus bx. And then a plus over here, 1 over b, cosine of a. Thanks for watching. We'll see you next time.